Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Just a quick video here talking about Hager RCCBs. Post the 18th edition, there's been a little bit of confusion about how to test Hager RCCBs because they implemented an update to BSEN 61008. BSEN 61008, which is the standard for RCCBs or RCDs, had an update in 2017 and it introduced the option for the manufacturers to have a 0.25 amp or a 250 milliamp test current to verify instantaneous disconnection. So instead of the times 1 times 5 scenario that we are so familiar with times 5 for a 30 milliamp being 150 milliamp, there was an introduction into that said that they could have 250 milliamp as an option. And it actually has this in the table under it as a note A. It says that the value is to be decided by the manufacturer for the test. So what Hager decided to do was update their RCCBs to incorporate the new 250 milliamp option. The problem with that is it's resulted in some change in the use or the wording of the wine regulations. So prior to the 18th edition, in the 17th edition, we had a regulation that we understood well, and the regulation said in 415, the old 415, it said the use of the RCDs with a rated residual operating current not exceeding 30 milliamp and an operating time not exceeding 40 milliseconds at 5I delta N. So it told us 5I delta N, which was 150 milliamp. The newer 415 has been reworded. The 5I delta N is not there. It says the use of RCDs with a rated residual operating current not exceeding 30 milliamp is recognized in AC systems as additional protection in the event of failure of provision for basic protection. That's it. No mention of the time. What they've done is they've taken that 5I delta and they've taken it to part 6 where they've added to it. So it's actually not got the mention of times 5. What it does say is the effectiveness is deemed to be achieved or verified if it disconnects within 40 milliseconds, tested at current equal to or higher than 5. So what this means is it could be 5, 150 milliamp, or it could be more. We could apply more current to the test. That's obviously allowed this option for the 250 milliamp to go in. The problem with this, though, was how we test it, because we're very much used to the times 1 and the times 5, and maybe the times half. And a lot of the multifunction testers have a very simple layout to accommodate times half, times 1, and times 5. We keep it like that. If you have a higher end machine, you may have the ability to test variable RCDs, in which case you can adjust that to 250 and you can test that at times 1 and you're looking for less than 40 milliseconds. It does say, however, or higher here, and the advice that Hager have given for this is if you have an MFT that doesn't do a variable, you could just set it to 300 milliamp, again, which is higher, and as long as the instantaneous disconnection time is within 40 milliseconds, then you're good. So that's a little bit of a way out of this problem. But Hager have received more and more complaint about this issue because it's been very frustrating and confusing for electricians. So what they have just recently done is they've just announced on Twitter, and I'll just read it here. Based on customer feedback we've received, we are pleased to confirm that we have improved our new RCCBs to align with the 40 millisecond trip time calibrated at 150 milliamp, which is the way we've always been familiar with. This is standard practice in the UK market, and they're now being fitted as standard in our products since the 1st of October. So since the 1st of October, from the line, everything is calibrated to adjust to the older 150 milliamp, which we are more familiar with. But this creates the scenario of we've had a year of RCCBs coming in off of the line where they are adjusted to 250 milliamp, not 150 milliamp. So the solution for that Hager have given us is the panels or the consumer units that this was provided with will have a label. They'll have a label fixed inside them, and I've got a copy of that label right here. And the wording of the label says, this type A 30 mA RCCB in this consumer unit conforms to BSEN 61008-1 2017. The test should be carried out at a current value of 250 milliamp for the 40 millisecond time. So from the 1st of October, RCCBs should be okay to 150 milliamp, the old way that we are familiar with. Since the introduction of the 18th edition, and for a good year, maybe even 18 months stretch, we've had RCCBs coming in, and they need 250 milliamp for instantaneous disconnection. Look for these labels if you're in a Hager board. If you're in a Hager board, look for this label, and it's very important if you're in a Hager board that this label is maintained and that you don't remove it or damage it. This is not a manufacturer's label that you just rip off after completion. This is a very important instruction to verify that ADS is achieved on a line of devices now that are in the market, that are out in the industry, that have now been tweaked back to how they were. But we need to make sure we are familiar with this line that requires a 250 milliamp or higher. And remember, if you see this, all you've got to do is set your variable tester to 250 milliamp. If you haven't got that, just test it at ×1 300 milliamp type device. Okay, so set your RC to 300 milliamp, test it at ×1, and you're looking for less than 40 milliseconds, and that is adequate. Okay? Just wanted to quickly put this out there because it's, Hager have been putting this feed on Twitter, but I've not seen any kind of announcement or anything about this, so I just wanted to make this here, should you be more familiar with this, want more information on this. Now, if you want to know more about how to test Type A RCDs or RCCBs, then other YouTubers have made some testing content on that. So have a look for those videos. But this is an update. Hager have announced that they're going to be taking these down to 150 milliamp now, and the way we're going to identify that one from the other is this label here. See you there.